root of 16 all over h1 to the power of 3 is this. So here we said first root of 16 is 2, because what the number, when it multiplies itself, it will give us 16. 2 times 2 we have 4, 4 times 2 we have 8, 8 times 2 we have 16. So first root of 16 here we have 2. Then what's the first root of h1 is 3, because 3 times 3, 9, 9 times 3, 27, 27 times 3, h1. So here we say 2 over 3, then to the power of 3. So this power of 3, we got it from the power loop. That is, the power must be 2 to the power of 3 all over 3 to the power of 3. The power must be distributed to both the numerator and the denominator. Then here we say 2 to the power of 3 is 8. 2 times 2 times 2. Here we have 8 all over 3 times 3 times 3 we have 27. This is the answer, 8 all over 27. Now we have another example here, 16 all over h1 to the power of minus 3 all over 4. The other one is 16 all over h1 to the power of 3 over 4. But this one has a negative sign here, minus 3 all over 4. So now let's start to clear the words. Let's clear the negative index, which is 1 over, here we have 16 all over 81, then to the power of 3 all over 4. Now here we say 1 all over, because the power here is 3 all over 4, so we have first roots of 16 all over each 1, then to the power of 3. Now here we say 1 all over. First root of 16 we have 2, then first root of 81 we have 3. Then we say to the power of 3. Now here we say 1 all over. 2 to the power of 3 we know is 8. All over 3 to the power of 3 we have 27. 1 over 8 all over 27. So here we now to take 1 over 8 divided by 27 divided by 1. If 27 I say over 1. So here we have 1 times 27, we have 27. All over 8 times 1, which is 8. So this is the answer, 27 all over 8. 18f to the power of minus 8 and also to the power of 3 all over 4. Now here we can say it further, because all the power what is there on the bracket is 3 over 4. Like the denominator here is 4. So we say it first root. Here is 4, then we say 16 all over. This one, we are going to take a reciprocal of f to the power of minus 8. That is, we put it as a denominator as f to the power of 8. Instead of it to be here as the numerator of f to the power of minus 8, we take it to be the denominator. That is, we now remove the negative index here. Then also we have a power of 3. Here is the power. So here we have first root of 16 all over first root of f8. So now here we say first root, we know first root 16, we have 2 to the power of 4. Then also here we now to say f2 to the power of 4. It's the same thing, because when we say f to the power of 2 times 4, it's going to give us back 8. So here we have first root of, so this first root, it will now go with this 4, and also it will now go with this 4 and the denominator. So here we say we have 2, first root cancel power of 4, then first root also cancel the power of 4. Here we have f to the power of 2. Then we have a power of 3. So now all in all here, this power it will touch 2, this power it will touch f. So 2 to the power of 3 we have 8. All over 2 to the power of 2 times 3 we have f to the power of 6. That is 2 to the power of 3 is 8. Then 2 to the power of f squared to the power of 3 again. That is from the power law. That is 2 times 3 we have 6. That is the answer. 4x squared all over 9, then to the power of minus 1 over 2. Now, let's start to remove the negative sign. That is when you have a fraction and also it has the power of a negative index. You can just take the reciprocal. That is, here we just to say 9 all over 4x squared, then to the power of 1 over 2. We now remove the minus, that's we take the reciprocal. Then after this, we now say that under a root power, we have 1 over 2. 1 over 2 is a square root. So here we say 9, here we say square root of 9 all over 4x squared. 9 all over 4x squared, then square root, because here we have a power of 1 over 2. That is the root. So now, in this case, here we say, what's the square root of 9? Or if we make it to be something different, that is to expand all the things, we can say 3 squared all over 2 to the power of 2, which is 4, then times x squared. So now, this square root, it will cancel this square, and also this square root, it will cancel this square, and also it will cancel this square. So here we have 3 to the power of 2 as 3, because the square root cancels the square. Then here we have all over 2, then here we have x. This is 3 all over 2x, because the root will cancel this square, the root will also cancel this 2, then the root also will cancel this square. This is the. We have another different thing here. 0.0081 then to the power of 1 over 4 is possible. Now, this 0.0081, we can make it because whenever you have an indices in this way, what you have to do, convert it to be in form of a fraction. That is this 0.081, we can now say 81 divided by 10,000. 81 divided by 10,000, it will give us what is here as 0.0081. Then here we have a power of 1 over 4. So, now as we have a power of 1 over 4, from the root power is first root. So we say first root of 81 all over 10,000. Now, what is the first root of 81? We now say 3 times 3 times 3 times 3 to give us 81. What is the first root of 10,000 is 10. 10 times 10 times 10 times 10. So now, if we want to take it in formal way, that is here we have 4. 81 is 7 as 3 to the power of 4 all over 10 to the power of 4. That is first root will go with power of 4. First root also will go with power of 4 on the denominator. Then here we have measure of 3 all over 10. 3 over 10 we know is 0.3 if we can take it in a decimal fraction. So this is the answer. We now to look at exponential function under an indices. Yes, what we call as exponential function is there is an indices that will now come with an unknown power or unknown base. When an indices have an unknown base or unknown power, we call that one as exponential function. Then, or we say exponential equation. Anyone? So here we have an example of exponential function. We now to solve them with the help of an indices. So now here, number 1, we have 2 to the power of x equals to 16. You see the power is x, is unknown. And also here we have 3 to the power of 2x. Also here we have another x is unknown. So we have to do all of this to have the power of x here. That is, let's start with the solution of number 1. That is 2 to the power of x equals to 16. What is going to be the power of x so that it will be 16? So now, here we have 2 to the power of x. We can express 16 to be the same base with 2. That is when we say 2 to the power of 4. 2 to the power of 4 is 16. So now here, we now to say equate. Equate the verse. Equate the verses. Because they have the same base as 2 and 2. So So we now to say the verse go with base. So x equals to 4. So when you put 2 to the power of 4 here, it's going to give you 16. This is the first one. Then we have to take the number 2. The number 2 here we have 3 to the power of 2x equals to 27. So now here we have 3 to the power of 2x equals 27. As usual, here we say 3 to the power of 2x. We can express 27 to be the same base with this. That is 3 to the power of 3. Because 3 times 3, 9, 9 times 3 is 27. So here we say 3 to the power of 3. So now we can say this is a verse of 3 and this is a verse of 3. We now to take the verses out. That is, equate the verses. So here we have minimum of 2x equals to 3. Then all divide both sides by the coefficient of x, which is equals to 2. So this cancel this. So our x equals to 3 all over 2. Then we have to take the number 3. The number 3 here we have 4 to the power of x equals to 32. In this one, we cannot take 4 as a normal base because we cannot have a base of 32 to be the same base with this. So we have to break the 4. That is, we say 2 to the power of 2x. 2 to the power of 2 is 4, then we have a power of x. This is equals to 2 to the power of 5 because 2 to the power of 5 is 32. 2 times 2 times 2 times 2 is 35. Is 32. So here we say we now to equate the verses. So here we have remaining of 2x equals to 5. So divide both sides by the coefficient of x, which is equals to 2. These two go with 2. Then x alone is 5 all over 2. This is the answer. We have another one here. X to the power of x minus 3 equals 32 to the power of x plus 2 all divided by 4 to the power of minus x. So now, here as we have 8, we can have 8 to be decimals with 32, decimals with 2. That is when we say 2 to the power of 3, it gives us 8. Then we have a power of x minus 3, we put it into a bracket. This is equals to 32 is the same thing as 2 to the power of 5. Then we now to put x plus 2 into a bracket. Then divide by 2 to the power of 2, that is 4, then to the power of minus x. That is, we multiplied, we say it, times minus x. So now here we say is 2 to the power of, this is, we now to open the bracket. 3 times x, we have 3x minus 3 times 3, which is 9. This is equals to 2 to the power of 5 times x, we have 5x, plus 5 times 2, we have 10. Then divide by 2 to the power of 2 times minus x is going to be minus 2x. So now as we have this also, then we can now say 2 to the power of 3x minus 9 is equals to 2 to the power of 5x plus 10 divide, because here is a division of 2 to the power of minus 2x. Then we now to look at the right hand side. It is from the second law of indices division. So here we can now say 2 to the power of 3x minus 9 equals to, they have the same base, and here it is a division. We just take 2. Then here we say 5x plus 10. Then the power, we have constant minus from the division, and also here is another minus 2x. So here we say 2 to the power of 3x minus 9 equals to 2 to the power of 5x plus, here is plus, then we say plus 2x, then plus 10. Then all in all here, we now to equate the verses. 2 go with 2. Then here we have 3x minus 9 equals to 5x plus 2x plus 10. Then we make a collect like terms. So here we say 3x, then minus Here we have 5x plus 3x, that is 7x. So here we say minus 7x. This is equal to 10 plus, because here is minus 9, when we take it here it's going to be plus 9. Then 3 minus 7x, we're going to have minus 4x. Minus 4x, this is equals to 10 plus 9, we have 19. So when we say divide both sides by divide both sides by the coefficient of x, which is minus 4, so our x alone is going to be 19 all over 4. Minus 19 all over 4. And that is the answer. We have 25 to the power of x minus 5 to the power of x minus 20 equals to 0. It's another exponential function because all the powers is unknown. So now, this 5 we can express the same base with this. That is, we say 5 squared. 5 squared is 25. Then we have x. Then minus 5 to the power of x minus 20 equals to 0. Then now, this one we can make a change. That is, we say 5 to the power of x. Then we make the 2 to be inside the bracket. It's accepted. Then minus 5 to the power of x minus 20 equals to 0. Then here we say, if you look at here, we have 5 to the power of x. Here also we have 5 to the power of x. We say let 5 to the power of x equals to be k. Wherever we see 5 to the power of x, we now put k. Then here we have 5 to the power of x, which is what? K. Then we say it has a power of what? 2. Minus 5 to the power of k is, we have another k. Then minus what? 20. This is now become a quadratic equation. It's now become a quadratic equation. That is k squared minus k minus 20 equals to 0. So you can use any method to solve this problem. So like here, we can have a factors of 5 and 4. These are the two numbers that if you multiply, that is when we have minus 5 and plus 4, minus 5 times 4, it will give us minus 20, then minus 5 plus 4, it will give us 1 here. So here we say the factors are, we have minus 5k and 4k. So we now to eliminate what is here at the middle. Then we say k squared minus 5k plus 4k minus 20 equals to 0. So we now remove this k because minus 5k plus 4k is to give us the same here. So we now to take a pairing. That is, here we say k squared minus 5k. We put it into a bracket. And also here we have 4k minus 20, we also put it into a bracket. All tends to 0. So now here we have a common, there is k here, there is k, we take k outside of a bracket. Then here we have a remainder of k, because the k is squared minus 5. We put it into a bracket. So what is common here? We have 4. Then what remains here? We have k minus 4 times what number to plus 20? We have 5. This is equals to 0. So we have k into k minus 5 into 4, k minus 5. So here we say we have k plus 4 equals to 0. Or either we have this and these are arcane and similar. We just take one. So here we say k minus 5 equals to 0. So when we have k plus 4 equals to 0, so our k is going to be minus 4. Or we now to say k equals to plus 5, because when we take minus 5 to this side is become this. So when we take 5 as the power, is going to be this. If you want to check, that is 25 to the power of 5, then minus 5 to the power of 5 minus 20, definitely is going to be 0. That is the answer. Now, this is how to test whether the equation can be factorized. So here we have a root of 12 squared is 144. Then we say minus 4 times 3. 4 times 3 we have 12. 12 times 9 we have 102. So we said we have 112 times 9, 9 times 12 we have, 108. So 108 all over 2 times 3, which is equals to 6. So 144, root of 144 minus this, we can now say 144 minus this, we have 36 all over 6. Then square root of 36 we know is 6. 6 divided by 6 we have 1. So it can be factorized, definitely. But since we have 3k squared minus 12k plus 9 equals to 0, so we can factorize it and see. Here we say 3k squared minus 12k plus 9 equals to 0. So now the factorization here, we can now say k squared, 3k squared minus 12k, then plus 27. Because we have to multiply the first number here of, that is the coefficient of k squared with what? With this 9, that is to give us 27. So what is going to be the factors of 27? That if you multiply it will give us 27, and if we add, it's going to give us minus 12. Then when we take 9 minus 9 and minus 3, it will satisfy the equation. So here we can say the factors are minus 9k and minus 3k. Because minus times minus will give us plus, 9 times 3, it will give us 27. So now we now to eliminate what is here at the middle. Then here we have 3k squared, then minus 9k minus 3k plus 27 equals to 0. So now we now to take a pairing, that is 3k squared minus 9k. Then here we have minus 3k plus 27 equals to 0. So we have a common of 3 and k. 3 can go into this and this. Then also here we have another k. So remainder of here we have k minus 3. Because 3k times k to give us 3k squared, 3k times 3 to give us 9k. Then here we have also a minus of 9, but here we have, here we are now going to put 27. We are now to put the original 9 from the first equation. So here we now to say minus 3 into k, then minus 3. Because minus 3 times k to give us minus 3k, minus times minus is this plus 3 times 3 we have 9. So now here we can say it's k, 3k minus 3, then and we have k minus 3 equals to 0. K minus 3 in the bracket, then here we have k minus 3 equals to 0. So we now to open the bracket, 3k minus 3 equals to 0, or either k minus 3 equals to 0. So here we can fit 3k equals to 3. Then divide both sides by the coefficient of 3 of k, which is 3. So our k from here equals to, we have 1. Then here our k is k minus 3. So when we take 3 to the other hand, we can now say k equals to 3. So either you take 1 or you take 3 to be the power is satisfied. This is exponential function.